Thank you for joining our situation brief, the 2026 tropical storm season and the shift from La Nina to El Nino. Before we get started, I have a few housekeeping notes. All attendees are muted, but please send questions using the Q&A box on the side of your screen. Please close any extra windows to prevent buffering, and we are recording the webinar and will send it out to you within 24 hours. Now let's get started. My name is Anne Sexton, and I'm joined today by my colleagues John Davis, our Chief Meteorologist, and Mark Russo, our Chief Science Officer. Today, John and Mark will take us through the tropical storm season outlook, and then we'll take your questions. Now, over to you, John.
Great. Thank you so much, Anne, and good day, everybody. So it's the time of year, it's May, that we begin looking ahead to the Northern Hemisphere tropical season, hurricanes in the Atlantic, typhoons in the western portion of the Pacific, and beginning to assess the risk of, especially in those two areas, key areas from a supply chain standpoint on a global basis overall. And why we do this at this time of year, typically the early portion of May, is this is the transition season. In the Southern Hemisphere, places like Northern Australia and Madagascar, the season, which is the last couple of months, is just now coming to an end. And this begins the transition to the Northern Hemisphere season, which typically is a little bit later into the summer, early portion of the fall, in the Atlantic, the Eastern Pacific, and the Northwest Pacific here overall, as well as the Northern Indian Ocean. So that is the area that we're going to focus on overall. But first things first, we're going to take a very macro look at things, and then we'll get more and more detailed as to the specifics of this season upcoming. And there's a couple of really interesting variables that will be driving the overall risk this year overall. So we're going to start with the biggest of pictures. We're going to begin with overall ocean temperatures, and ocean temperatures, of course, are the drivers of tropical storm activity, all areas of the world. So let's start with the biggest of pictures overall. So this is the current global sea surface temperature anomaly map. So areas in red feature above normal temperatures. Areas in blue, like up toward Alaska in the North Atlantic, those feature below normal temperatures. As you can see in most of the world, and certainly most of the major oceans in the world, there's a lot of warmth out there. There's a lot of warmth in the Pacific, in the Indian Ocean, in portions of the Atlantic Basin overall, and certainly that warmth is a driver as we go toward and approach the Northern Hemisphere hurricane and typhoon season here, upcoming. And when we look at global ocean temperatures, and if we compare that historically, the warmth that you see here, it has been going warmer and warmer for many, many decades. So if we take a snapshot today of overall, sea surface temperatures, this is going back all the way to the early 1980s to the current situation. This year is the red dotted line up top. So if we average out the overall global oceans and we look at every year from 1981 to this year, every day features the average of global ocean temperatures. On the x-axis, we start that in January, go to late December for every year out there. Of course, the averages, over the last 30 years and 40 years are much, much lower. Decadally, the global oceans have been increasing. They've been getting warmer and warmer. And we've reached a very interesting time frame, actually in the last week or two, is that the global oceans now, the current temperature on average, has gone to the highest levels that we've seen in the historical record. That's the first time that's happened in the last couple of years. In the last couple of years, for example, looking at 25, which is kind of the orange line there, it was always basically kind of number 2 or number 3. It was never the tops. So the first time in the last 2.5 years, overall global oceans have gone to levels that are the warmest. Some of that is the El Nino event, which we're going to talk about at length here coming up, but then the general trend of warming oceans overall. Why do we care about this? Well, we care about this because global oceans and the ocean temperatures that we have, that is what drives hurricane and typhoon and all tropical activity. The warmer the oceans are, the more octane or energy individual systems have for areas of the Atlantic, of the West Pacific, of the East Pacific here overall. And the more warmth that we have, that is the more potential energy that you can have in storms overall. Now, when we look at the data, this increase in global ocean temperatures, it does not produce an increase in the numbers of tropical cyclones on a global basis. But what it has done, it's increased the intensity of the strongest storms overall. And of course, in the supply chain world, when we look at that, it's always the Category 5 hurricanes. And this is just kind of looking at things in the Atlantic basin here, overall. And what you've seen is not an increase in the overall numbers, but an increase in the extremely strong storms. And those extremely strong storms are the ones that cause the biggest damage, the biggest economic loss, unfortunately, the most deaths and injuries, and by far the biggest impacts to the supply chain. So this is an example of the intensification of storms that we see. We call that rapid intensification at times. If we compare the Cat 5 hurricanes, the big events, the big disruptors in the supply chain. And again, that would be categorized as winds in excess of 157 miles an hour, steady winds overall. If we look at the last 25 years of last century, 75 to 2000, we had 7 Category 5 hurricanes in the Atlantic basin. During the first 25 years of this new century, including last year, we've had 21. So 3 times more Category 5 hurricanes, the big events, the big disruptors within the supply chain. And again, this is a function of long-term warming of the global oceans, the Atlantic, but it's also true in the other global oceans here overall across those areas. So from a macro picture, the global oceans have increased risk overall of the most devastating storms, the Cat 4s, the Cat 5s out there. That's true in the Atlantic. It's also true in the Pacific and true even in areas of the Indian Ocean overall. So that's starting this presentation in looking at the macro picture, the biggest picture of them all. Let's now begin to whittle things down a little bit and talk about some of the details that are really important here for this year. So when we look at overall ocean temperatures, and we go back to this map, so again, a lot of red. So there are individual areas which impact different tropical basins of the globe. Now, we're not going to go into great depth on water temperatures in the Gulf of Mexico, water temperatures in what we call the main development region, the MDR, things that are a little bit, on the warmer side, but that's not the big driver here going into this year. And that's more of a feature once we get into the core of, hurricane season and core of typhoon season here later on. The big driver this year is what's happening in the equatorial Pacific. A major event looks like it's going to be developing, has already developed across those areas, and it's the El Nino event. The warmer than normal waters in the central and eastern portion of the Pacific, that is going to be the dominant driver, the biggest variable, not only of the Atlantic hurricane season, but also of typhoons in the Pacific, both in the East Pacific, for example, on the west coast of Mexico and even into California and in the West Pacific overall. And again, from a supply chain standpoint, the number of major ports, the population across those areas in China, in the Koreas, in Japan, in the Philippines, that is one of the biggest ramifications as to what will be happening overall with this developing El Nino event across those areas. So for this specific season, the 2026 season, the big item on this map is the warmth in the equatorial Pacific, which is going to continue to ramp up by every indication out there and become a very strong event by the time we get to the heart of the season here in the Northern Hemisphere, July, August, September, and October. And with that, let's get into more details here. I'll hand it over to Mark, and we'll talk about some of the specifics out there.
Thank you, John. Well, to show the relationship with this intensifying El Nino and what this means in terms of tropical activity across the basins around the world this season, we're going to start here. And we've shown this in previous hurricane outlooks. And for reference, we start with what we call ACE, or accumulated cyclone energy. Why do we use this metric? This metric, we feel, is a better metric as it incorporates not only the numbers of tropical systems, but their intensity and their duration over their lifespan. So we think this is a great metric for risk. And on this chart that you're seeing right now, this is a chart of Atlantic Basin ACE since 2000. All of the high number years, those are active seasons within the Atlantic, typically a higher number of storms, higher number of stronger storms, and also longer duration storms. So seasons such as 2004 and 2005 and 2017, those are the top three highest ACE seasons going back to 2000 in the Atlantic Basin. And then at the bottom part of the chart is the lowest ACE years. Those are the inactive seasons here. And so you can see a lot of year-to-year variability, but overall, we've seen some very active seasons, also some inactive seasons. When we look at the average of all seasons since 2000, the ACE average is 150 here. So that is a good starting point. Just going into any season, historically, since 2000, ACE values average out to be 150. So that's a good starting point. Now we factor in with this developing El Nino, and what does this mean for the Atlantic Basin in terms of risk? So now, taking these ACE values, we now incorporate all of the seasons that are either at El Nino levels, neutral levels, or La Nina levels across the equatorial Pacific. And that's what this chart here depicts. All of those red bars that you see are El Nino seasons since 2000. And then all of the blue bars indicate the opposite of El Nino, La Nina, or cooler waters across the equatorial Pacific. So when we look at all of those El Nino years, which this season is going to be an El Nino season, it's already developed, it's going to intensify, it's likely going to be a very strong El Nino later on this year in terms of intensity. So this season in the Atlantic Basin is going to be impacted by this El Nino. And that is a suppressor of tropical activity across the Atlantic Basin. Reason being is that with the El Nino event, that increases wind shear, actually that across the Atlantic Basin, especially in around the Gulf of Mexico, Caribbean. But for the basin overall, that suppresses activity. And then the most active seasons, again, at the opposite, that was La Nina. That has actually have been more tropical seasons here in the past 10 years or so. But this year, again, what makes this year unique is that this is going to be an El Nino season. Last time this happened was back 3 years ago in 23. ACE actually averaged out to be close to normal that season. But prior to that, 2015 was a very suppressed season. Same with 2009. And then also 2002 was that way as well. So bottom line, with this El Nino event, and rapidly intensifying El Nino event, this is, we think, suppressing the risk in general across the Atlantic basin. Now, just to hone in a little bit more on U.S. coastlines, both Gulf Coast and East Coast, here's a little study on landfalling storms, either tropical storms or hurricanes since 2000, and the influence of El Nino and La Nina. Let's take a look at the left map and table. So these are all El Nino and La Nina landfalls or tracks of storms since 2000. And since 2000, there have been 9 landfalls during El Nino seasons. La Ninas have featured 15. So specifically in the Gulf of Mexico, so for if your business operations, supplier locations, facilities, or transportation networks or hubs are located in the Gulf of Mexico region here, again, that's a suppressor. Historically, there's been a fewer number of landfalls there on the Gulf Coast during El Nino seasons. On the East Coast, El Nino, La Nina doesn't make as much of a difference. You can see that kind of equal distribution there, 16 and 17 between El Nino and La Nina seasons overall. And just looking at some of the tracks though, you can see that at least within these seasons, well, either one, you tend to have, again, more activity in the southeastern part of the country. Again, that's kind of, normally the case here, but up further up north, you can have impacts of systems, but again, it tends to be pretty rare. But overall here, because of the El Nino event, some of the most suppressed risk is actually in the Gulf of Mexico region here because of this intensifying El Nino. So that is a key takeaway from a risk standpoint, looking ahead for this upcoming season. Now, on the other side here of the globe, in and around the Pacific, and whether it's the Eastern Pacific or Western Pacific, that is where the highest risk is going to be this tropical season. And that is due to this El Nino event. And if we take a look, a similar study here of all El Nino events going back, or all tropical seasons in the Western Pacific Basin since 2000, and we look at all of the El Nino seasons, that they tend to be very active here. And certainly much higher ACE and much higher risk historically in the Western Pacific area compared to La Nina seasons, which are typically suppressed. And so with this upcoming season here in the Western Pacific, that is where the highest risk is going to be. So for any global operations, business operations, transportation networks in countries like China or Taiwan or in and around the Hong Kong area, Korea or Japan, that is where the highest risk tends to be. And same is true for the Philippines and at times Vietnam and Thailand. Although specifically for those areas of Vietnam and Thailand, La Ninas can tend to shift storms further to the west and impact those areas, such as what we've seen with typhoons the past couple of years during La Nina seasons there. But with this year being an El Nino season in countries such as Vietnam and Thailand, at least compared to the past couple of seasons, we think that that risk is a little bit lower here overall. And rather that higher risk is further to the north, again, in around Taiwan and China, the Koreas and Japan, which have seen actually fewer systems or impacts here in recent years. And then lastly here, Eastern Pacific and even Central Pacific for like states like Hawaii, but then for the Eastern Pacific in around Mexico and the Southwest US, El Nino events tend to enhance tropical activity, and due to also some warmer than normal waters around, also that is also a higher risk zone for being impacted by some of the heavier rainfall associated with remnants of storms that move into that area. So bottom line here, for this tropical season and preparing in advance for this season here with your supply chain operations and transportation networks here, one of the key takeaways is that Atlantic Basin has reduced risk overall for tropical impacts. And that is being driven by this intensifying El Nino and what looks to be a very strong El Nino as we go through the remainder of this year. And from a coast standpoint, a risk standpoint here on the US Gulf and East Coast, we are anticipating at least reduced numbers of storms driven by this El Nino event and higher wind shear. However, we do need to keep an eye on every storm, as John mentioned before and pointed out with some of the anomalous warmth in the Gulf of Mexico right now and Caribbean, is that any storm that does develop and tracks over anomalously warm waters could result in more of rapid intensification and ultimately a stronger storm. So while there could be fewer numbers of storms, again, those storms that do develop could still be quite impactful depending on where exactly they track. Also of note, another key takeaway, Eastern Pacific Basin here has increased risk versus climatology of tropical impacts. So like I mentioned before, places such as the Southwest US and Mexico. If your supply chain network involves those areas, then overall there is a higher risk this season here of being impacted from the tropics here. And also of note, due to some of this anomalously warm waters off the coast of Mexico and the Southwest US, also there's increased risk of, especially off the coast of Mexico, some of the storms being very potent here and potentially more impactful. And then lastly, again, the Western Pacific Basin, East Asia supply chain, business operations and transportation. Overall, that has a higher risk here compared to normal or climatology this season. And again, that's markedly different from the past two seasons where we had more of a La Niña influence and suppressed activity across areas of the Western Pacific. And then two other items to keep an eye on here before we open things up for questions. Again, as John mentioned before, with this increasing number of Category 5 storms, Category 5 storms, the strongest storms here, the most disruptive storms to supply chain networks. That's also something we need to keep in mind as we go through this season. And we do feel there is an increased probability of rapid intensification due to still a lot of ocean warmth around in the tropical basins here in the Atlantic and also the Pacific. So another thing to keep an eye on, and again, with every storm this season, we'll be providing details on the risk of rapid intensification in our watchtower alerts and in our advisory services. And then the other item of note is that, again, also related to the increase in global ocean warmth, that there is a higher likelihood of storms tracking further to the north and impacting more northern locations, and such as what we've seen in recent years, including storms such as Helene, which created the catastrophic inland flooding in places such as the Carolinas. Again, another impact of this trend in increasing ocean warmth, and also something to monitor with every storm here as they make landfall. So with that, we're going to open things up for questions. So, Anne, any questions?
Yes, we've had a few come in. Let's dive
Awesome.
right in. For the US coast, what zone has the highest chance of having a hurricane?
That's a really, really good question. So it certainly is not the Gulf of Mexico. And even in the Western Gulf of Mexico, that is the area that's least likely. But if you had to pin one area, the highest probability, if you will, or chance of having an impactful hurricane, it would be the areas, further east. It would be the east coast of Florida, up into the Carolinas possibly. That would be the area that would be more and more likely, mainly due to the fact that El Nino has a greater suppressor impact in the Gulf of Mexico than it does in the Atlantic. It's further away from the event here in the equatorial Pacific. So yeah, east coast of Florida into the Carolinas, that would be the area that's more likely to have an impact of a hurricane than other areas on the U.S. coastline, especially, over, let's say, Texas and over, the western areas of the Gulf of Mexico overall. That's an awesome question.
I've got another really good one for you. Could the El Nino forecast be wrong?
Interesting question. El Nino, well, the short answer is pretty much no, because we're technically in El Nino levels right now with this rapid warming of waters across the equatorial Pacific. So no, El Nino is here right now. It's going to remain in place. The biggest question in our minds right now is just how strong is it going to be? And there's been a lot of chatter over the past month or so about this El Nino event potentially being a mega or a super event, which we haven't seen one of those types of El Nino events since 2015. And in fact, since 1980, there's only been 3 mega or super events, 2015 being the last, 97 or 97, and then 1982. Back in 23, that was a strong El Nino, but not quite up to mega status. So we think that's the debate. Like, do we reach 23 levels, or is it more like 2015 levels? And if anything, right now, probably starting to lean more 2015, a potential mega, as just water temperatures continue to just rapidly warm in that key area of the equatorial Pacific.
Right, so it's definitely happening. It's just a question of how strong it's going to be.
Exactly.
I have a few more questions for you. Will there be another major inland flood event in the southeast?
Oh, yeah, kind of thinking of Helene, and of course, Helene was just devastating impacts across the southeast Appalachian area. Still some areas have never recovered, from that overall. It's a good question. Of course, the overall risk in the Atlantic Basin is lower this year because of the rapidly intensifying El Nino event. But for storms that, let's say, move into the southeast, into the Carolinas, the real risk is if those storms tend to stall out in inland areas, then you have a major inland flooding event. That was the thesis of overall Helene and the devastating impacts that we had across the area. Due to warm oceans, so we started the presentation overall, due to very high levels
Did we lose you there, John?
Sorry? Hello?
Your sound's been cutting out, John.
Oh.
Yep.
We can hear you. I can hear you, John.
Oh, okay. Yeah. So that the reason why we have those events is that storms all over the world, they're getting wetter because of more higher ocean temperatures, more precipitable water, and so the storms that we have tend to have more rainfall associated with them. And the risk is if we tend to see a storm stall out. That was Harvey in Houston, that was Helene a couple of years ago. And if they stall out with the more potent water, and they tend to have more moisture associated with them, that's when you have these inland flood events. So from a macro standpoint, the mere fact that you have less risk this year, well, that reduces that risk. However, for an individual storm, can you get the setup where a system moves inland into the Carolinas, for example, and then stalls out and produces major flooding? Sure, that risk is there. And that risk has been increasing for the last couple of decades. Again, going back to the warming that we've seen with global oceans that have occurred for many decades here overall.
So another question from the audience. Do you anticipate hurricane seasons to last longer than traditional timing?
Yeah, another good question there. Yes, but although that is dictated by how warm the oceans are during the particular season, the fact that this season here has very warm water temperatures, even with the suppressed, with the suppressed activity expected in the Atlantic, that actually could cut things down a bit. It's more so those La Nina seasons, those active seasons that are also combined with very warm waters. Those have an extended seasons, typically with potential storms in November within the basin. One other item is that for this season, if there is going to be a more extended season, it's probably across the Western Pacific, or even for that matter, the Eastern Pacific here. Again, due to the warmth and then with El Nino and enhancing activity across the Pacific Basin, that's where that risk window will likely be extended here.
I'm afraid that's all we've got time for, so we should wrap up the session. But if people have further questions, please email us at info@everstream.ai, and obviously we will get the recording over to you in a day. Thank you very much for your attention. It's been a great session. Thank you very much, Mark and John. And here's to an interesting El Nino.